Okay, hello everybody. Welcome to this video lecture on operations research. So we are considering in this lecture about solving product mix problem with GLPK revisited. So in lectures on chapter 4 we did this, and now we are doing this again slightly differently. So in principle you should already know how to do this, and we do it slightly differently so you wouldn't get overly bored. So what has happened so far? So we have had this more deep bakery problem 5.1 here, where more deep bakery bakes cakes. Three types: Atreides, Korinen and Harkonnen. And the cakes, they take some nutrients. So here is nutrient powders: fat powder, sugar powder, protein powder, water powder, and spice melange powder. And each cake take different amount of these ingredients, these powders, and there is limited supply of them, and then there are here the selling prices for each cakes. So what we did, so we then basically took this table here and interpreted it as an LP, which pretty much entails nothing more than taking this selling price, this here the objective, the daily revenue to be maximized is defined, put it not in the last line but the first line, and then put here inequalities for the availability. So we ended up with this. So really that was basically remark 5.4, that the LP in here and the table in the problem are basically the same thing. So what we have to do now we have to solve this, and of course we are not solving anything by hand since it's in the 20s, in the 21st century. So we do have computers now and they are rather good, so let's use them. And so then the problem is to somehow tell this to a computer. And depending on what kind of software you are using, you explain this or express this to the software in different ways. So we are using GNU Octave. So GNU Octave, that is a MATLAB clone. It's a matrix oriented. I mean, it understands matrices very well. Basically almost everything to it is a matrix. So it makes sense to write this in a matrix form. And now the neat trick here is that if you look at these numbers times these variables and just formally think of vector x as x1, x2 and x3, then if you collect what you have here into vectors, you see that if I take these coefficients 120, 170 and 100 to be a C, so remember I assume that everything is a column vector unless otherwise stated. So I take these coefficients here as a column vector, so somehow this column vector C identifies with the objective function. Then I take all the numbers in this block here, so these numbers, and collect them into a matrix that I call A. So this is a technology matrix. What does it mean? It's technology matrix. It somehow explains us or tells us what kind of technology we are using. So what is a technology? Here technology is how we turn nutrients, so this fat, sugar, protein, water and spice, into the products, that is the cakes. They are not named here, but this column could be called Atreides, this column could be called Corino, and this column could be called Harkonnen. So this is somehow the technology we are using. And then these upper bounds here So this is the availability of each nutrients. So let's take these numbers. So it's a vector, collect them to a vector called B. And then formally, just if C, A and B are defined in that way, so C is here, A is this here, and B is here, then I can just write this 5.3 in the following form. It's the maximization Z equals C transpose X subject to AX is less than or equal to B and X is bigger than or equal to 0. So this 5.5 is simply a compact form of writing this 5.3. They are the same. Okay, so it's nice to have a compact form for it, and what is even nicer is that now we are ready to solve this with GLPK. So the problem data is basically C, A and B, and then we have to somehow tell Octave also that there is only upper bounds here, and we are doing a maximization. Alright, so this is what we do next. Of course, before going there, maybe I should point out, so this is somehow just a remark to see how things are related. So LP in tabular form. So now we have this kind of LP maximization, C transpose X subject to AX less than or equal to BX bigger than or equal to 0. So if we go back to the original problem, so here we have the table like this. So if we formally put the matrices and vectors here in the table, then we see that this LP here corresponds to this kind of table schematic. So we have Fremen cake types and nutrient powders, ... They can be any name and any number of them. Then we have a technology matrix here, selling price here as a, okay, I always have column vectors, so then C prime or C transpose a row vector, so it's a row here, and availability to be other columns here. Okay, so there's nothing deep here. It's kind of just to get you an idea how if you have a problem data in this way, then you immediately see that this will be the LP associated with it if it's a product mix problem. Okay, so now the next thing is to solve this with GLPK. So for that we do as we have done previously. So we make an M file, that is a script file that solves it, and it's listed here. So 5.7 solution, Muad'Dib Bakery revisited. So here is the listing of the M file, and then there are some explanations how it works, and then there is the Octave discussion that gives us the solution. And let us go through this file, how it works. So we have seen this solution already, of course, in chapter 4. There it was a script file called muad'Dib.m. Now this is muad'Dib underscore revisited.m. It's almost the same, but not quite, so that you don't get overly bored. So let's go through this solution also, and again, usually it's a good idea to go through code with the actual application software that you can write the code with. And for that, let's download this code that is listed here. So you can download it by using this link. Just click it, and hopefully something reasonable happens depending on your system. I cannot tell what happens. In my system, it actually opens this kind of dialog. So it actually passes this PDF file that has this link to Firefox, and then the Firefox opens the link and asks what should I do with it. Should I open it with text editor or save file? So I ask it to save the file. Alright. And now apparently it did it. And yes, in some systems it probably now asks where to save it. In my system it does not. It has a default directory or folder, if you like that name, for it. So I have to search there. So I open my file manager here, and it's actually, for me, it's down. It's the folder where it goes. Your system, it's probably downloads or something else. You should know where where your web browser downloads files. So here it actually is. It's this more tip underscore revisited.m. Okay, what do we do next? Next, we should move this file to our working directory. So what do I mean by working directory or working folder? So you should have a designated folder in your computer for this course. So that's a place where you should maybe put the lecture notes and all these M files and maybe also the exercises you do. So that the name of that folder is, yes, whatever you like. For me it is, you will soon see. So I right click in my system, move to, and then here that's my home. Under that I have a folder work. Under that I have a folder teaching, and under that, as you can see, a lot of teaching. I have a spicy underscore OR, spicy operations research. That's just the name I chose for it. Okay, now it looks that I have a correct folder there. And then, okay, so now select should now move it there. Okay, now I get this kind of error message. There's a file conflict saying that there is already a file with that name there. Well, obviously, because I've written it. In your case, you probably don't have, so maybe it doesn't ask anything. It just moves it there. In my case, actually, I will skip this. I will use the one that is already there, and I actually even delete this. Okay. So what is the situation now? Situation now should be so that this modtip underscore revisited.m text file should be in your Octave's working directory. So next thing to do is to start Octave. I can do it by using this sidebar. In the Ubuntu system you have it somewhere else in your system, so just look for this kind of logo. So some kind of circle, I suppose, blue one with orange squares. I have no idea what that's supposed to mean. In any case, clicking here and waiting for a while, we get a window something like that. Let me make this window slightly smaller so it's not under my face. Okay. You should get something like that. And now apparently I noticed that I have now using version 6.3.0. When I started these notes it was 6.2.0, but apparently my system automatically updated this to the latest version. As far as I know, there are no real differences, at least as this course is concerned. Okay, now the first thing is of course to try whether this modtip underscore revisited works. So let's, how do you do it? You just type the name of the script file, m file, without the .m, and this would give us, well, this would execute the script and thus hopefully give us the solution. Okay. And if I do this, well, I know this is not going to work. I do this because this is probably something that you will experience very often. I get this kind of error message. Error, mod tip revisited undefined near line 1, column 1. So that's a very technical and strange way of saying that what you typed is not defined. So mod tip underscore revisited is not defined. What does this mean? Shouldn't it be the file? Well, the problem you see is here. It's the current directory. And for me, when I start Octave, the current directory is always /home/t-sottinen. That's my home directory. Again, when you start your own system, it may be something different. It may be the correct, it may be the working directory. It should be, but quite often it's not. So we have to change the directory to the correct one. And this can be done in many ways. I will now use the way I've used here quite often. When I work myself, I never use this way because it's too slow. But maybe I use this because it's maybe most obvious to you. So here is the current directory, and there is some kind of a folder icon here, which is browse directory. So I click that, and now I get my home t-sottinen, and there are what I have here. So what was my Octave directory for this course? It was work, teaching, and spicy OR. It's here, and then choose. And now you see that the current directory is changed. Also, if you have these panels here open, you can actually have the listings of the directory, and you can actually see there that mod tip revisited is actually there. So let's try again. And now I can type mod tip revisited again, but of course, being efficient or lazy, take your pick. I just press the arrow up on the keyboard. So this looks the command history, that this gives me the previous command. It's there, and let me type it. And okay, I get something. Apparently this is the solution. And well, yeah. What does it say? It says that Xmax is like this, so 171 point something Atreides cakes, 246 point something Corino cakes, and no Harkonnen cakes at all. And then the Z max, so this would be the weekly profit, will be 6.4 blah 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 E plus 4 Solaris. So for some reason Octave likes this, I don't know, scientific notation. So this of course means that E plus 0.4, that this decimal points has to be shifted 4 times there. So it's something what is 62,466 Solaris. Okay, let's not care too much about this number format. So at least it works, and it gives the solution, and you should compare this solution to the one we had in chapter 4 to see that it's the same. If it's not, then at least one of them is wrong, of course. Okay, so what do we have left? We should next look at the actual code. So how this what is there in the mod tip revisited.m, and again, since I want to keep these video lectures relatively short, this is given in the next video lecture. See you there. Bye.